So in this final module, I want to go over a little bit related to how we can deal with some of our data in 3 dimensions. Now, most new GIS programs have ways of viewing things in 3D. In ArcGIS, we have 2 different ones. We have ArcGlobe, which is for large-scale things. It tries to kind of be like Google Earth, anything where the curvature of the Earth is going to be important. And then we have ArcScene, which works in true 3D, so it's better for small phenomena without kind of spherical projection on it. So if we wanted to look a little bit at ArcGlobe, we're not going to experiment with this much in the demonstration, but I encourage you to look at it on your own. It essentially looks a lot like Google Earth, where you can add your GIS layers and manipulate some base layers in there as well. And then ArcScene has this sort of planimetric 3D view, where we have our layers kind of stacked on top of each other. So the differences between 2- and 3-dimensional visualization in ArcGIS are essentially that the different layers can have different roles in the 3D view. They can be used to describe the surface. The ordering of them in the table of contents is not particularly important because the elevation is what's going to actually control what's on top of one thing or another. The extent of a 3D view is handled quite a bit differently. When you're zooming in and out, you have additional dimensions that you have to work with. And drawing priority can be a bit of an issue. Simply because something is on top of it in the table of contents doesn't mean it's going to necessarily draw on top of it in the actual thing, even if the elevations are the same. So we have multiple different types of 3D data that we can work with in ArcScene and in ArcGIS. Some of these are vector. Any shapefile can be what we call z-aware or elevation aware. It can have z coordinates associated with the points, the vertices that are within it. So this could be points, lines, or polygons. They could all have sort of elevations in there. You can store the elevation for any feature in the attribute table as well. For points, this works quite well. For points and polylines, it works a little bit less well because they're all going to be at the exact same elevation. So you need to decide kind of how you want to have it stored in there. And then you can also drape features over a pre-existing topographic surface. With raster data, a DEM or a TIN can be displayed using its elevation values so that it actually displays as if it was in 3 dimensions. And then any other raster images can be draped on top of these as well. And we'll see what this looks like both in these slides and in the demonstration as well. One thing I do want to stress here, though, is that in most cases, GIS data are not truly 3D, they're 2.5D. What does that mean? Essentially, it means that for any given location in the same layer, you can only have one z-coordinate. So you could never do something like a cave, where there's 2 elevations, the top and the bottom, for the same x and y coordinate. You'd have to have those as separate layers. So it requires a little bit of manipulation in how we work with it. Now, if we project, say, a digital elevation model in 3D, like what we see here, you see it looks like staggeringly nothing. That's because generally, we need to put some sort of vertical exaggeration on to really be able to see the specifics of differences in elevation over a large area. This is particularly true for northern Indiana, where we're pretty flat. So once we put some vertical exaggeration on, you can see that we really do begin to see a 3-dimensional visualization and rendering of this surface. Now, if we had, say, a satellite image that was not topographic, that was not 3-dimensional, we can then take that and drape it over top of our surface so we actually see it in 3D also. We can do that with polygons, polylines, really anything. These are drainage polylines from the hydrology demonstration, the hydrology module. And we can drape those over top as well, and it really gives us a good indication of where drainage is going and why it's going along those particular paths. We can do that with soils, polygons, really anything. What we can also do is we can do what's called extruding on our features. This only works for vector data. And this essentially stretches it upwards so that we can see it a little bit more clearly. So if we wanted to extrude these features, things like lines would become walls, things like points would become kind of pillars, and polygons would become kind of an abstract geometry that goes up in 3 dimensions. And we can use this to sort of artificially create structures in there that let us visualize some things that we might not be able to see as well. So in this case, what we have is a shapefile that's been created that has, for each little section in there, in those polygons, each polygon has a height field associated with it, ranging from 1 to 4. So I can put that shapefile in, drape it over the surface, and then extrude them based on that height field. So I'm not limited to just saying like stretch it up 1 meter. I can say stretch it up however many meters are listed in the attribute table. And let's do things like create a castle or create some sort of architecture in ArcGIS. Now, when we're dealing with the visualization tools in ArcScene, there's a couple of other toolbars that we'll experiment with a little bit. We can do some of our 3D analyst tools. We can do some of our spatial analyst tools. We can do a little bit of vector editing in there. But though I encourage you to do these things in the 2-dimensional version because it's much, much more streamlined. There are some other effects that we might want to work with. We can change how each layer is displayed. We can change whether or not it's being shown as transparent, how it's being lit, whether the light is actually affecting it, what the depth priority of particular layers are. And we can also record animations. So we can record either very complicated navigations around our 3-dimensional view, or we can record very simple movies of it spinning. We'll experiment with both of those during the demonstration for this module. But I want to just leave you with a little bit of one of these visualizations, a little animation of flying around a castle on Notre Dame campus.